Good morning, everybody. Yeah, as you see, we are a group number 7, and we are standing here as teachers of physics, and we are going to have a contribution on this lesson. It is Unit 1. The topic we are going to discuss about, or the lesson that we are going to teach you, is propagation of electromagnetic waves in free space. First of all, let us introduce ourselves so that, as you see, everyone will contribute to the to all steps of the lesson. My name is Nagashema Joseph. I am registered in year 3 MPE at 22302412. And I will be the one to introduce this lesson. I can let my fellow group member to continue.
Good morning once again. Okay, my name is Odas Nigena with registration number 223081 and 95.
Yeah, good morning. My name is Neomukiza Pacific. I'm with the registration number 223014908.
Morning once again. My name is Oyes Vanessa with registration number 223015233. Thank you.
Good morning. My name is Trinayo Evode with registration number 223011388.
Good morning. My name is Dirwe Solange. My registration number is 223011439. Thank you.
Yeah, thank you very much for this introduction, introducing ourselves. As you know, on the timetable, we have, of course, physics. We are going to study physics. We are on this lesson. It is propagation of electromagnetic waves in free space. When we talk about free space, it means, as we will see, there is some conditions or there is some variables that will be equalized to 0. And within this lesson about propagation of electromagnetic waves in free space, as the previous lesson discussed about it, you discussed about the Maxwell equations. So we will build on that Maxwell equations to see how electromagnetic waves are able to travel in free space without needing medium. So within this lesson, as we have tried to put together different teaching strategies that should be used, all of the strategies will be employed within the steps this one is going to follow, and we have chosen to use the 5 E's traditional model so that you can understand well how electromagnetic waves propagate in free space. So let me call upon Miss Vanessa to continue with the next with the first E of 5 instructional model, and I would like to invite you to be active in this lesson so that by the end of this lesson you will be able to explain how electromagnetic waves travels in free space. Thank you.
Morning again. As I have said, my name is Wise Vanessa. I'm going to continue with this session. Yes, all of you are ready for this session. I'm inviting you to be attentive because this lesson is very interesting. Yes? Let me start by asking question. Who can tell us the meaning of electromagnetic wave? Chantal, can you help us to understand the meaning of electromagnetic wave? Thank you very much. Clap for her. Who has another idea? Jeremy, can you help us to understand what is electromagnetic wave?
Electromagnetic wave are a wave which created by the combination of electric field and magnetic field.
Yes, thank you very much. Clap for him. Now, who can tell us the examples of electromagnetic wave? Example, at least one example. Yes, thank you, Maxine.
One example of electromagnetic wave, I can say ultraviolet light.
Yes, ultraviolet light. Who can tell us another?
Yeah, I can say right wave.
Yes, thank you very much. All answers are correct. Now we are going to see in a video. It is an interesting one. I'm asking you to be attentive. Definitely, I will ask you some questions about it.
How exactly do satellites receive signals from space and then send them back to Earth? Let's imagine waves of heat as energy carries from through the ocean until it hits the shore. Satellites also use hydrogen waves called microwaves, which send signals from space to Earth with temperature, air. These waves are formed by powerful devices inside the satellite. Great sunlight, electromagnetic radiation. Sound familiar? The microwave oven in your kitchen also uses the power of microwaves, which hit your food and give it energy. In this challenge, your goal is to send signals through a wave machine. The microwave signals that satellites send travel through space and are received by an antenna and recorded on a computer. The wave signals your example set travel through the machine and are received by the mark recording on a computer. Make sure to observe how the energy of the wave changes depending on how much energy you put into it. A high energy wave will report a higher signal, whereas a low energy will report a lower signal. Learn how satellites navigate space by building your own wave machine design.
Yes, thank you very much. I think everyone has enjoyed the video, yes?
Yes.
Now, what comes in your mind after seeing that video? Jennifer, can you help us? What have you understood in that video? Yes, stand up and tell us. What have you understood from that video? Yes, thank you very much. Pacific, can you add something on that? What comes in your mind after seeing that video?
What I have seen in the video, I have seen some tools on the screen. Dump down and up, vice versa, so that I can get idea of somehow the it's showing us the way the propagation of wave.
Thank you very much. Clap for him. I think everyone here, there is someone who has a question about this lesson, but everyone here, I want that at the end of this lesson, we will be able to answer this question. Say that how do Maxwell's equations govern the speed and straight line propagation of satellite radio signals through the space? Yes, I'm asking you to be attentive in order that you will be able to answer that question. Yes? Thank you very much. Let me invite another member to continue.
Good morning, class. Now we are going to continue our session. So the activity we reach on. As usual, you are going to join your respective groups. Yes? Now, join your groups so that you are going to do this activity. This activity is about, everyone see here, you are going to hypothesize how a change in the electric field affects the magnetic field and vice versa. So you see here Gauss's law of electric field, of magnetic field, and Faraday's law of induction. Here also we have Ampere's law with Maxwell's correction. So you are going to hypothesize. So in your groups, yes, in your groups, using this, also this one, using this. Using this. The question to discuss about is those. Analyze and identify which ones involve time-varying electric field and time-varying magnetic field in free space. And also, you are going to discuss the interdependence of the electric field and magnetic field as described by the two Kerr equations, Faraday's law and Ampere's law. Have you finished? First group. First group, have you finished? Present your findings. Okay, if the first group is not ready, another group is ready to present their findings. Which one? Group number 3. Okay, go to present your findings.
Thank you. In a group, have discussed about the time varying equation regarding on the Maxwell's equation, and we have obtained Faraday's laws and Maxwell's and Ampere's law with Maxwell's modification. Thank you.
Okay, thank you very much for your findings. Now we are going to invite another group member to continue on the following content. Thank you.
Good morning once again. Okay, we are on the topic of propagation of electromagnetic wave. As the previous group has been discussed about, we have seen 4 Maxwell's equations. And so, because the electromagnetic wave, it is a wave of course, it can propagate in wave function, like in sinusoidal wave. So, in our findings, we have seen that electromagnetic wave propagate perpendicularly to each other. Mean magnetic wave must be perpendicular to electric wave. Magnetic wave or magnetic field wave can be perpendicular to electric field wave. As you see in this chart, is everyone able to see here? Okay, from you see, this is the direction of electric field, and this the direction of magnetic field. There exists also the direction of propagation of wave. You see, it is just like a chart, but in reality, the magnetic field must be perpendicular to electric field. As you see, this is electric field and this is magnetic field, and this is the propagation of wave. Okay, from this, can you scroll up? Okay, from this, the previous group has shown that the Maxwell equation satisfies the wave equation by using Faraday's law. We are not going to repeat the case, but I am going to show that Faraday's law satisfies the wave equation by using Ampere's law of modification. Yes? Okay. We have different Faraday's law, different Maxwell equation. We have first one, the Gauss's law for electric field, which says that and the Gauss's law for magnetic field, which is, we have also Faraday's law we have also Ampere's law of Maxwell modification, which is are these correct? Are these all correct? This is not the new content because the previous group has been discussed a lot to this. Okay. From this, we have to show the propagation of electromagnetic wave in free space. Know that in free space, the charge density is equal to 0, as well as current density is equal to 0. Okay? Now, can you imagine, can you think about how can charge density is equal to 0 in free space? Who can answer this question? Why and how is charge density equal to 0 in free space? Why? Mr. Gervais?
Thank you. In free space, charge density equal to 0 because in free space there is no matter, there is no charge and no ions.
Okay. Thank you. Thank you very much. In free space, there is no charge, no matter, no ion. Reason why? Because this charge density is equal to charge with respect to volume. If there is no charge, means charge is equal to 0. 0 divided by volume will be 0. And also, this is current density, which is equal to the product of charge density and the velocity will be equal to 0 because we have no charge density. So, from this, we can derive how this Ampere's law of modification satisfies the wave equation. Yes? This is the Ampere's law. Okay. From this, in free space, the Maxwell equation now becomes, the first one becomes, which is, this is the Gauss's law of electric field will be equal to 0. The second one will remain unchanged. Will remain unchanged. The third one also will remain unchanged because there is no effect of current density as well as charge density, right? Okay. This is will remain unchanged due to lack of influence of charge density and current density. Yes. Okay. This one will become the Maxwell modification of Ampere's law will become this will be 0. Okay. From this, for equation 4, we are going to apply carry on both sides. Okay, apply carry on both sides, and we get the curl of which is equal to curl of where is another chalk? Okay. From this we get the curl of this will be equal to which is equal to minus the Laplacian of B, which is equal to, of course, here we let this carry act on electric field directly. From this, if you remember well, in free space, this represents the Gauss's law for magnetic field, which must be equal to 0. Reason why? Okay. Reason why this will be equal to 0 and will remain with which will be equal to by plugging in the value of this. You see, this shows the Faraday's law will be equal to you see. Okay, from this we have which is equal to okay, you see, from usual noun, you know that the wave equation is will be equal to 1 over v square okay, from this we see that v is equal to 1 over from this comparing this and this equation you can see that v is equal to okay, because it is in free space, if you plug in the value of this electric permittivity of space and this magnetic permittivity of space, you will get v which is approximately 2 meter per second, which means the velocity in free space. Okay, this is what I was supposed to show you. I think if there is no question, I can end my presentation here and invite another colleague from my group to proceed with the next steps.
My name is Trinayo Evode with leg number 2230113888. So now here we have a scenario to read, and after reading it, you will respond how you think from a scenario given. A deep space probe is sending data back to Earth. Explain the physics of how a data which starts as signal in a probe antenna actually travel millions of kilometers to reach our receiver dish. Focus. They must explicitly use time varying fields, propagation in three space and speed of light. Then, according to this question, you are going to do basing on what you have done. So, using a given sheet, then discuss. Try to discuss with your colleagues. So, have you finished? Okay. Here there is an expected answer. First answer is a time varying field. Next. Second is the medium of travel propagation in three space. Then third one is a speed limit. Thank you. Let me invite another colleague to proceed.
Good morning once again. Thank you. I'm here by the name of the restaurant. We are going to continue uh, with summary. And first of all, we have to take a papers and make a summary. Individually, make a summary about this lesson we have learned. Okay? Do it quickly. You have 3 minutes. Summary about this lesson, what you have learned in this lesson, okay? Because after you have to do a task, I'm going to give you. A question in here, we are going to work on it, is about which pair of Maxwell equation, when simplified for free space, explicitly demonstrate that a change in one field can generate the other, enabling self-propagation. Okay, do on this question. You are done? Okay, thank you. As you have done, let's continue with homework. Okay, homework I'm going to give you. You're going to work on it when you are at home. Okay, at the next session you're going to give it to me. Okay, thank you very much.